Hello, Tanya Laird here, and let's see. So this is part 5 of lecture 11 of ENGR 2301 Engineering Statics. Now, I know in part 4 I said part 5 would be the last part, and we would really get to the examples in part 5, but I think there's actually one minor little thing I'd like to go over first, and then we'll save the examples for a more proper, longer video for part 6. So this will be potentially a record for this course in terms of number of videos in a particular lecture. But the thing I wanted to cover, and I thought might deserve its own video, is looking at how to determine if a frame is statically determinate. We have learned how to find whether a truss is statically determinate using a very simple equation, but we haven't learned yet how to see to find whether a frame is statically determinate. And really, it's actually not too bad. So this is just going to be frame static determinacy. How do you determine, before you start running through a whole bunch of equations, how do you determine whether you're going to get lost in those equations? Well, hopefully you're doing the math right. That's one way to get lost in the equations. But another way is if the frame itself is statically indeterminate. If the frame is statically indeterminate, it doesn't matter how good you are at your math and your engineering, without using things like mechanics of materials and elastic theory and that sort of thing, using just statics alone, you're not going to be able to solve for all those member forces using statics alone. So how do you know if a given frame is statically determinate? Well, the basic method works like this. 1, draw the exploded view. As we've discussed previously, label all exterior forces or exterior reactions and joint forces, member end forces, or internal member end forces, I should say. Two, your number of unknowns. Now, this is simply going to be equal to the total number of forces revealed, the total number of forces named. And because each individual member is a rigid body, your number of equations is going to be 3 times the number of members you have, the number of members. And therefore, if your number of unknowns is equal or less to your number of equations, then your thing will be statically determinate. Then your system will be statically determinate. So for example, let's look at something here. Let's look at something that's definitely not going to be statically determinate right off the bat. Let's say I have an entirely fixed frame. If my pen can quit from jumping around too much. Here. So if I want to then draw an exploded view of this, and I should probably say number of unknown forces named. I'm not including any like known forces applied to the outside of this thing. Those don't count as unknowns because usually we already know the magnitudes of those and directions of those. So if we have this, something like this. Well, and we don't actually need to draw all of them out. If all we're trying to do is determine whether this thing is statically determinate, it's relatively simple. We don't have to necessarily draw all of them out. We realize at a fixed joint, there's going to be this sort of thing going on. There's going to be a force transfer in the x direction, a force transfer in the y direction, and a moment. So I don't actually need to write out every single one of them if all I'm trying to do is determine static determinacy. What I might do instead is just say, okay, well, there's going to be 3 member forces, 3 end forces here. Yes, there's going to be 6 arrows altogether, but there's only going to be 3 forces. Then on this one, I'm going to have 3 forces. Same kind of thing, a fixed joint. Then down here, I'm going to have 3 forces because it's a fixed support. So we'll have a moment, a force in the x direction and a force in the y direction. And then down here, we'll have the same thing at this joint or this support here. So in this case, we have 12 unknowns. But we only have 3 members, which means we have 3 times 3. This is the number of members. This is the number of equations of equilibrium we get from each member. Each member is a rigid body. It's a 2-dimensional rigid body. So we have only 3 equations of equilibrium. So that's 9 altogether. 9 equations. And if we wanted to solve all this, we couldn't. We have 3 more unknowns than we do equations. So I would say this is statically indeterminate to the 3rd degree. This can be analyzed using some things from structural analysis, but we would not be able to solve it using the laws of statics alone. To the 3rd degree. Okay, what if this frame were a little different? What if I had, say, what if I had something like this? Let's see. I'm trying to do this so it doesn't collapse, though. That's the tricky thing. If I just made a pin here and a pin here, that wouldn't quite do. Well, here's one thing you could do. What if we said this frame, instead of having fixed joints, maybe it was something like this. A fixed support here. Maybe a pin connection here. A beam. A pin connection here, and then down here we have a pin support. Now I'm just gonna draw this as line elements. There's just 2 different ways of drawing. Don't be confused on the beam drawing or the drawing with some dimensions to it versus the line drawing. For this, they're the same kind of thing, just a little quicker to draw. And I'm gonna look at the number of forces. Again, I could draw out the arrows Fx, Fy. Or AX, AY, all that kind of thing. But for this example, all I'm looking for is to determine whether it's statically indeterminate or not, and its degree of static indeterminacy. So if we don't really need to write everything out if all we're looking for is the degree of indeterminacy. So on this reaction, or on that support, I have 3 forces because it's a fixed support, and that represents 3 unknowns on the frame. Then this pin joint, that represents 2 unknowns. This pin joint represents another 2 unknowns, and this pin support represents another 2 unknowns. So I have a total now of 6 unknowns. 2 plus 2 plus 2 plus 3 is, oh sorry, not 6 unknowns, 6 from here, but then plus 3 is 9 unknowns. I have 9 unknown member end forces, unknown forces. But I have the same number of equations. I have the same number of rigid bodies, the same number of members, and so I have the same number of equations. So now 9 equals 9. This is now statically determinate. And we could solve for this using nothing but the laws of statics alone. Just laws of statics alone, we'd be able to solve for all of the member end forces, and as we'll see in the next lecture, we'd also be able to solve for the member internal forces like shear and bending moment. This is sort of a prequel. This lecture is sort of a prequel or prelude to that. And that is the basic idea. Also, note, it's important to note, you cannot cheat by you might be tempted, at least when you're working through this the first time, to say, oh, what if I just cut this in the middle? Isn't that just the same thing as making one member into 2 and then having another, just treating like, can't we just treat one member as 2 but joined by a fixed joint? And the answer is yes, you absolutely can do that. But the problem is that will not help you at all with your indeterminacy. Because the problem is, yes, if you cut it, you do now have 2 individual rigid bodies, which means which means you get another set of 3 equations of equilibrium. Unfortunately, when you cut that thing out, what is now a fixed joint, well, you've created 3 more unknown forces. And so yes, you get 3 more equations, but you also get 3 more unknowns. And unfortunately, that's not going to help you in terms of equilibrium or static determinacy. You'll have, yes, your number of equations increases by 3, but your number of unknowns also increases by 3, so you didn't really get anywhere. All right, that'll do it for this portion of the lecture. I just want to give a very brief video, relatively brief, 10 minutes, covering how to determine whether a given frame is statically determinate. And finally, at long last, in section 6 this time, we will actually start looking at some examples of finding and analyzing simple basic frames and simple machines. All right, please let me know if you have any questions on this. If not, I'll see you soon for part 6, and as always, thank you.